Okay, so this video is the first video on inferential statistics. It's not going to have very many examples because it's just an introduction. It's trying to explain what these are, more or less. Now, I've written down in red here. So inferential statistics is information that can be upscaled to represent an entire population or a larger sample. So if I wanted to know the most popular brand of jumpers in my class, if I have 20 students, that's easy. I could find out in 5 seconds or 10 seconds, 20 seconds, it depends. If I wanted to know the most popular in first year, that would take a little bit more time, but again, depending on the school, it would work. You could find out easily. But what if I wanted to find out for something for the entire population of the school? Now, if you're from a small school, that could be easy enough. Your school might only have 200 students. But some schools could have 700, 800, 900, even over 1,000 students. You couldn't ask every single person that question. So what you would try and do is get a sample, and from that sample you can then upscale, like I said a while ago, the information that would represent the entire school body or the school population. It happens a lot as well with, say, political parties. It's in the newspapers every now and then that this certain party is the most popular because we interviewed 2,000 people and that represents the entire country, or kind of bits of information like that. That's what inferential statistics are. Now, I've one or two examples here. They're not concrete, they're not exact, like there's no exact science unless you physically go around and ask every single person. But the maths has found that an appropriate sample can give a very accurate form of information. It can give a right number. Okay, so I'm just going to give a quick example here. So a school has 1,500 students, loads and loads of students. So we're not going to be able to ask all of them. We survey 400 students for their favourite foreign holiday destinations. So Spain, Italy, Portugal, France, wherever. Okay, now what I'm going to use, just to make the numbers a bit easier, we'll say of the 400 students, we'll say 200 picked Spain. Okay, 200 students picked Spain. So that would represent 50% of the school prefer Spain. Now, as I said, this could be true. It mightn't be true, but just for the example, we're just going to say that it's close. If I sampled 600 students, 50% would mean that approximately 300 students would prefer Spain. If I had 1,000, if I wanted to know about 1,000, 500 of those people would prefer Spain. That's just an example of it. Now, it could be very, very, very close because we have a fairly big sample size. But there's also something called a margin of error. Okay, this bit is important. This bit of information is important. It's a margin of error. So if I wanted to prove something to, we'll say, a principal, that, look, I know for a fact that approximately 50% of the school prefer to go to Spain on a holiday, so that's where I think we should send our next school trip, or something like that. Now, the principal could ask every student, and they might actually get a result that would say 47% of people. So because your number isn't exactly right, they'll say, well, no, that doesn't work. So that's where the margin of error comes in. You're not going to get an exact number unless you ask everybody. So the margin of error is like an allowance. Like if you said 50 and the answer was actually 49, well, you're fairly close. Okay? Now, there's a few different types of margin of error, but the most basic one we're going to look at for the minute is this one. So the margin of error is 1 over the square root of n. Okay, that's the most basic one at the minute. And n, as you've probably seen in maths all over the place, when you see n, that just means the number of. So the number of people. Now, we have two numbers. Is it 200 or sorry, it'd be three numbers actually. Is it 200, is it 400, or is it 1500? So N is the number of people, but this part is important, surveyed. That is very important. So N is the number of people that was surveyed. So my margin of error is going to be 1 over the square root of, I surveyed 400 people, so it's 1 over the square root of 400, which is 1 over 20, which can equate to 5%. Okay, that's my margin of error. Now what that means relative to this percentage, the 50% that I found a while ago, that means my margin of error is allowing me 5% either side of my predicted number. So it would be 50% plus or minus 5%. So that would mean that my lower limit would be 45% and my upper limit would be 55%. So if I got a result of 50% from my 400 students, I could be fairly confident that the real answer is between 45 and 55%, which is fairly close. Now, it's not bang on, but it's fairly close. So, just to carry on, I found out that my margin of error and my interval would be 45% to 55%. I'm fairly confident that my actual number is in between here somewhere. Now, I've said the same two words a couple of times. It is very important. It will come up in your exams. You will spot it. A confidence interval. So I am confident that this interval is correct. Now, in our exams, the most common confidence interval that you will have to work with is 95%. Okay, that number will consistently come up. So in an exam, it might say something like, with 95% confidence interval, or the CI for confidence interval, they might say, with 95% confidence, can you find the actual number? Now, what this means is if I carried out this survey 100 times with different groups of students every single time, I would be 95% confident that this answer will come up. So my answer will be in here. So I'm 95% confident that out of the 100 cases, 95 of those cases will give me a number between 45 and 55. That's what a confidence interval is. Okay? So this formula that I've written down here, I've actually used this already in the video, but this is the official proper maths way to explain what's happening. So we have P with a little triangle on top. That's called P hat or P cap, whichever you prefer. So I call it P hat. So P hat minus E less than P less than P hat plus E. Now the letters underneath explain what it is. P hat is the sample proportion. So if I look at the example that we had a second ago, I did 400 students, 200 picked Spain, that was 50%. This 50% is my P hat. That's my the proportion from my sample. So P hat will be 50. P is the actual proportion. Now that's the number we're not going to, more than likely we're not going to find out because it's too complicated to find all the information from so many people. So P is the actual number. And E is the margin of error. So again, if you look back to the bit that I had a while ago, I said 50 plus or minus 5%, which gave me 45 and 55. Now, to use the formula, we know that P hat was 50, and we knew that the margin of error, which had worked out from here, 1 over the square root of n, 1 over 400 came out as 5%. So P hat is 50. The margin of error was 5. So 50 take away 5 gives me 45. The actual answer is in here. We don't know what it is, but we believe it's in there. And this one, p hat, again, is 50, plus e, which is the margin of error, which is 5, which brings us up to 55. So I had actually done this a while ago without you realising that this is what you're doing. Now, this is what you might see in the exam, but do not panic if you see it. It's literally just finding your proportion, finding your margin of error, add it, subtract it, and that's all it is. Okay, in the next video I'll do a couple of examples to show exactly how the confidence interval works and a few real life examples of where it comes up.